Okay, so we were doing log base A of 0.0005, which we originally wrote as 5 over 10,000. So that's a quotient, log base A of 5 minus log base A of 10,000. Okay, and then we rewrote that as log base A of 100 squared. The log base A of 5 we're just kind of carrying along. We bring the 2 in front, 2 log base A of 100. 100 is 10 squared. So we bring that 2 times 2 is 4, and 10 is 5 times 2. So now I just have to break this up into minus 4 times log base A of 5 plus log base A of 2. And the final step is distribute that negative 4 through. So we have log base A of 5. Oops, 5 there. Minus 4 log base A of 5 minus 4 log base A of 2. Okay, so and then the last one was log base A of 1/10. That's the log base A of 1 minus the log base A of 10. Log base A of 1, that means A to what power is 1? That's just 0. Minus log base A of 5 times 2, which is log base A of 5, plus log base A of 2. So we get negative log base A of 5 minus log base A of 2. I rewrote it in terms of log base A of 5 and log base A of 2. Now, to solve an equation, instead of rewriting it as a logarithm, one thing you can do is just take the log or natural log of both sides. Okay, it's an equation. You can do the same thing to one side as you do to the other. Now, the reason I would take, doesn't matter if I said log or natural log, both of them are on my calculator. Those are buttons on my calculator. But the reason that I take the log of both sides is so that I can use the property which says then that I can move this exponent in front. And the exponent is what has the variable. Once I move the exponent down front, then I can isolate my t by dividing both sides by everything that's multiplied by the t. 12 natural log of 1.025. Okay, I forgot my natural log here. Okay, so anyway, I took the natural log of both sides, brought the 12t in front of the natural log of 1.025, divided both sides by 12 natural log of 1.025, and now on my calculator, I can take the natural log of 3 and my parenthesis, divided by parenthesis 12 times natural log of 1.025 and my parenthesis for the 1.025 and then end my parenthesis for the 12 times natural log of 1.025. I get 3.7076. About 3.07076. Okay, so I'm saying that if I take 1.025 raised to the 12 times 3.07076 power, I should get pretty close to 3. So I might want to do that on my calculator as well, just to check my answer. Take 1.025 to the 12 times 3.07076 power, and you should get very, very close to 3. 3 point, okay. So try the rest of these, pausing me if you want, to make sure that you understand it. You're getting the same answers, okay? Let me erase this for now so that I can show you the next problem. So I would take the natural log or the log. Let's do log this time. The log of 1.00012 to the 365t power equals the log of 2.4. I do this so that I can bring the 365t in front of the log of 1.00012 equals log of 2.4. We're going to divide everything except, the t. So I have log of 2.4 divided by 365 log of 1.00012. And then we'll see what we get. When I do that math, I get 19.98906,996. Okay. Alrighty. Now, for this problem, I don't have my variable in the exponent. Right? Do you see the difference there? You don't have your variable. Your variable's right here. Okay. So I'm going to divide. I'm just going to use my, how I know how to solve a problem. Undo everything. I have 1 plus r over 360 to the 7/20th power equals 12 divided by 5. Okay, divide both sides by 5. I have to undo the 7/20th power. So I'm going to take the 7/20th root. Okay, that gives me 1 plus r over 360 equals the 7/20th root of 12/5. I'm going to subtract 1 from each side and multiply by 360. Okay, multiply both sides by 360. Okay, so that's going to be fun to do on the calculator. I think I would 7/20th root. I like to write that. It's easier on my calculator to write that as the 1 over 7/20th power. Okay. Just like when it's square root, I write it as 1/2. Okay. So I would do that on my calculator. Okay. Number 86. X is at the bottom. I'm just going to make that x to the 2.3 equals 12.33. I'm going to raise both to the 1 over 2.3 power. So on my calculator, I'm going to take 12.33 to the 1 over 2.3 power. Okay, you get 2.9808. 2.9808. Okay, same thing here. X to the negative 3.2 equals 0.915. Okay, so let me extend this a little. There we go. X to the negative 3.2 means 1 over x to the positive 3.2. So then if I multiply both sides by x to the 3.2 power and then divide by 0.915, okay, and again, I'm going to raise both sides to the 1 over 3.2 power, because that undoes x to the 3.2 to the 1 over 3.2 means it's just going to be x. So on my calculator, I'm going to take 1 over 0.915 to the, use that little caret, to the 1 over 3.2 power. 1 divided by 0.915 to the 1 divided by 3.2 power. 1.028. X is 1.028. So we want to be able to, like you can tell, go fluidly back and forth between exponential form and non-exponential form. Let's try this problem again. We want to know when 2,500 is going to double if it's compounded daily at 6%. Okay. I still would divide, first of all, by the 2,500. Okay, but since my variable is 365t, since my variable is in the exponent, I'm going to take the log of both sides. We didn't do that last time, right? We didn't take the log of both sides. Last time we simply rewrote this as a logarithm, but you can just take natural log or log of both sides, which then will allow you to bring the 365t down in front. Okay. I took the 365 and put it down in front. Divide everything. I have natural log of 2 over 365 natural log of 1 plus 0.06 over 365. And see what you get when you put that in your calculator. When I put that in my calculator just now, I got about 11.55 years, which you can remember is what we got the other way. Okay, so if you don't want to change it to exponential, go back, change it to log form, you could use this solving equation idea, which is to take the natural log of both sides. Okay.